Right. So thank you very much, everybody, for coming by. I realize we are on the third day and it's in the afternoon. So either you're here because you really, really want to know this, or you've stumbled into a random room. Either way, I do hope you're able to walk out of here with some useful information. Yeah, let's get going. Just a super quick introduction. My name is Reiner Block Anderson. I've been with Splash Damage Games for about 2 years now. Moved here from Canada. And whilst at Splash Damage Games, I was responsible for the migration of all of our current build systems for our projects from what they currently are to Horde. This included everything from the infrastructure deployment, configuration of servers, software configuration, networking, user support, all of it. So it gives me a little bit of an insight here into Horde that I'm hoping to share. To be clear, I do not represent Epic in any way. Horde is built by Epic. They own this, they develop it. I just happen to be a person who uses it, likes it, and wants to talk about it. The plan here, I have 3 main goals here. I'd like everybody to be able to walk out of here being able to describe what Horde is. I'd love if you can have an understanding of whether or not it would be useful to your company or not, to your teams. And then whether, if you are going to transition to it, what a transition from your current build system to Horde might look like. So that's the objectives. We'll see how we get on. Before we get too far into this, I just want to kind of quickly level set on what a build system is. You don't have to agree with me on this. I just want for you to understand when I say build system during this, what I mean. You can have a different definition. That's up to you. But if we Google build system, we get this wonderful definition. Fundamentally, all build systems have a straightforward purpose. They transform source code written by engineers into executable binaries that can be read by machines. For us, and I think many people in the games industry, we can simplify that and say, build systems take our Perforce depot and produce a thing our players can play, right? Other things along this line might include Jenkins, TeamCity, GitHub Actions. There's many of them, right? A couple of extra things that I think are important in a build system. They need to be fast. Games industry especially is a very collaborative and iterative thing. We need to be able to work together and try new things. So the faster a build system is, the better off we are and the more we can get done, right? So any build system that takes that fast and really tries to help amplify that is important. They need to be automated. If the build system isn't automated, it's just Stuart from the build team, and he has way more Perforce knowledge than anyone should, and he's way more valuable to your company than you ever care to admit, right? And then finally, they need to be informative. If the build system isn't informative, then Stuart's just now F5ing the build status page and messaging people on Slack, right? But if we have an informative build system, our developers have confidence in the system, they have confidence in their builds, they can fix problems quicker, and we generally have a more stable build, right? So before we continue, a quick little disclaimer. Horde is not considered production ready. Of my 3 objectives I listed, I did not include for you to go back to your company on Monday and deploy Horde. It's not ready for that. We're a little bit insane, and I think you'll understand this more as we go. There's some problems here. What is Horde? The thing people probably really want to care about. If you read the README from Epic, this is how they describe it as a scalable, cloud-ready, distributed build framework and content addressable storage platform. Again, more buzzwords, right? If you read the list of goals that they have there, it's a fairly ambitious set of goals. But the final item on that list is what I care about and what I'm here to talk about. A CI/CD system for teams to test, build, and publish their projects. It's a build system, right? Hence the discussion of build systems. So for a quick little point of clarification here, I am going to be talking about a part of the Horde ecosystem that is known as Horde Build. There are other parts. I may just simply say Horde during this presentation, but I am referring to Horde Build, not all of Horde. Also note, they specifically call it that it's designed for Unreal. I love TeamCity, and we will continue to use TeamCity at the company for things that are not Unreal, but there's basically no other build systems that are built specifically for Unreal and are public. Also note this line down here, just to sort of drive it home. Epic says it's not ready for production because it's not. Okay, so I've told you not to use it. I've told you we still use it. Why is that? Why do we use it? What makes Horde special in comparison to other build systems? First and foremost, and maybe not foremost, but it's first on this list because this is important to me. I was the one who was responsible for deploying, running, and managing Horde. And so for me, it being a modern application, and what I mean by modern is just it's a newly written thing with new concepts. So from day one, we had a Docker image. We can deploy that. We can scale it horizontally. We can back it with S3 or file-based storage or Horde storage, which I don't know about, we've not used. And just generally, it's easier for us to work with, right? It's written in C#, which if you're an Unreal developer, you probably have some devs who have Unreal or C# experience because all of the rest of their tooling is. So it's a newly designed and built application that is easy to work with. It's a build system that has Perforce as a first-class citizen. Very few build systems out there actually have Perforce as a first-class citizen, right? For us, this is awesome. For many people, this kind of writes Horde off, right? If you don't use Perforce, Horde's not going to work for you at all. But yes, for us and whoever else in the industry uses Perforce, this is actually really wonderful. And then it's integrated with the engine. This was a point from Epic, but they followed through on it. With many build systems, pretty much all the build systems, you will have your project and you will have the build system, and you need to tell them how to work together, right? You need to tell the build system what steps depend on which other steps, what files or artifacts need to be transferred between build agents, what can be run in parallel, what is a warning, what is an error, how do you display test results. All of those kinds of things are the extra bits you have to put on top. The underlying understanding of what you need to do to build a project doesn't actually change, right? You still need to understand all the commands and steps you need to run to build your project, but the extra stuff on top, that's where Horde starts to stand out. Now, all of these points I've listed, they're reasons I like Horde, and I think many people will like Horde, but they're not the reason we use Horde, right? At the end of the day, the people who use this, my customers, are the development teams. They are the ones who matter. Their opinion matters. If they don't like it, then it's been a giant waste of time, right? So the number one reason why we use Horde is the developer experience. It's basically unlike any other build system we've used, and it's because of all those integrations with Unreal and whatnot. But yeah, it's wonderful. I mean, as I said, other build systems exist, and they're usually built for generic developers. They're not even usually built for game developers, whereas Unreal is built, or Horde is built specifically for Unreal. So I've told you a little bit why we use it. Let's go through a little bit of a tour of how it looks to use and some of the features that are there. First up here, and these screenshots all come from our production system, so apologies for the censoring. Yeah. But this is the dashboard that you get when you load Horde. First thing you'll note is we can see, oh, did that picture slide? Oh, that bothers me. Apologies. First up here, we can see which projects you have access to, right? Very simple. We can see what issues are assigned to you. So Horde will detect issues in your builds and can assign them to users. So again, we can see those right here. And we can also see very clearly what builds we've triggered manually, the things I care about as a developer when I load Horde, right? Here is a picture, a screenshot from one of the development streams of one of our active projects, right? As I said, this is from a live thing. First here, you can see the categories at the top. These are all customizable. These are not predefined. We, as the development team or the build team, can choose what categories we want to show. This can change by stream, by project, but we have the flexibility and the control to show our users what they need to see. Next up, we have all of the jobs that have been run. In this case, we're in what we call our continuous integration category. So this is a job that gets run on every commit for everything continuously all the time. And through here, we can start to see one of the things I really like. Most build systems, they'll tell you the status of a job, not the parts of a job, right? Here, I can tell, well, the build passed, but it had some warnings. Or parts of the build passed and parts of the build completely failed, right? I don't have to drill into a specific job to understand these different parts of it. I, at a glance, can understand very clearly what's going on. And this is configurable by the build team as to what information gets shown here. So it gives, again, it just gives us flexibility as a build team to show our users what they need. Next up would be these tabs or these columns at the top. Again, configurable. We get to choose what's shown, what columns are there. And you'll see that when we switch to, actually, sorry. One of the other things is you can hover over these, I actually don't know what they're called. I think labels, I think is what they call them. But you can hover over them and understand what steps from the build process contributed to that status, right? So if we had a failure, we can understand if there were multiple steps in that failure, what of those steps contributed to the failure versus some other steps that succeeded still. Here, we're looking at a different category. We're looking at our full builds category. So in comparison here, the previous one, we had an author column on the left because this was running on every change. We want to know who committed that CL. Here, we're looking at builds that are either triggered once a day. In this case, there are nightly builds, or could be manually triggered. We don't really care who authored the CL at this point. We care who triggered the build. So instead of author, we have a build column, which tells us what job template was run. And then on the right, we can understand who triggered it. In this case, they were all scheduled jobs, right? One of the things that's been really, really nice to see is that Epic has been smart about what features they develop. Some build systems try and reinvent the wheel, and it's just a little wasteful. Here, this little context menu, there's links to Swarm. If you are using Perforce, you probably have Helix Swarm. Why reinvent the wheel? They will just link to Swarm for the given CL. You can see the files, see the diff there, and it's just a smart and efficient way to build this product. There's also, if you'll note, there's a new job button at the top right. If we were to click that, we'd be presented with something like this. Again, a lot of flexibility here. In this case, for this job template, which we call our nightly full build, we, as the build team, have decided we want this job to be the same every time it's run. We don't want to have to question what options were chosen or anything. This job runs the same every time. So there's no options. You can start that job template and on you go. Compare that to this template. We have some options we can present to our users. Again, configurable by us, the build team. Our devs don't have to have any understanding of what the underlying command line args that are being set. We can put whatever command line args we want behind any of these options, right? It's just some simple checkboxes. What clients do we want built? Windows, PlayStation, whatever it might be, servers. We can choose a cook package, and we can let our devs choose if they want to upload this to Steam, and if so, what branch of Steam they want to upload it to. It's wonderful. If you were to click on a job or start a job, you would end up at this page, the job details page. Fairly straightforward. We have a list of all the steps that have been run. We can see how long those steps took. It's basic, but it gets the job done. If you were to scroll down on this page, just a little bit further down, you would start to see this, which is the health section. So this will show you all of the issues that have been identified across any of the steps on your job. So again, Horde is looking for warnings and errors. There's some simple regex parsing. You can add your own regex parsing if you want to specifically check for certain things. And then when warnings are identified, or issues are identified, I should say, Horde can send Slack messages. If it identifies which user created that issue, it can tag them in Slack. It can be linked with Jira to create Jira tickets. All of that right through your build system, which is wonderful. Again, if we scroll down a little bit more, this is a little bit hard to see, but it's a bit of a terrible graph, but it's a very useful graph. We can start to understand over time how long our build steps are taking. So we can very quickly identify, is our build time increasing? Because it never goes down. And if it's taken a big jump up, what CL introduced that, right? It's the kind of functionality everybody wants, but you usually have to build separately. Here, presented very easily, built into the whole thing. If we were to click on the logs for a job, it's logs. How wonderful could it be, you say, right? But clearly you can start to see we have warnings and errors highlighted. So when you're just quickly parsing logs, you can see that. To the left of the warning itself, we have the issue number that's associated with that. If we were to click on that issue button, we would be presented with a dialog that tells us what streams is that issue happening in? When was it first identified? What CLs is causing it? What other jobs is this issue appearing in, right? We can also see who the issue is assigned to, all of that kind of stuff. And then we can also, instead of having to like Control F error, just simple next previous buttons. It's wonderful, it's simple. And one of my features that I like is there's a little drop down at the top right, and you can change the timestamps on the left from being relative from the start of the job. So instead of trying to figure out how, this is 8 minutes into the job by original time, subtract, no, none of that. Just relative time, you can see it, but you also have access to local and UTC time. So very, very handy. This is I couldn't find a screenshot that showed what I wanted to do without heavily censoring it, sorry. But what we can see here is that these are errors instead of warnings. We can also see that, I don't know if you can see it, but the issue number there has a strike through it. So this clearly tells me, the user, that this issue has been resolved, either probably in a future CL, but that what I'm looking at, this issue has been resolved. And then this here, it's a file path to a CPP file, or a header file in this case, but it's not just blue because the Epic wants to mess with your brain and make you think it's a link. It is actually a link. If you have Unreal Game Sync installed, if you were to click that link, it would open P4V time-lapse for you. So you can see the state of that file now and the history of that file. Super simple. We get Gauntlet test automation test results integrated as well. So long as you're running a reasonably newer version of the engine along with Horde, Gauntlet will output the test results in the correct format, and the Horde agent will upload them, and there you go. Whoops. This is a feature that I'm still trying to get the studio to use more, but for me, whenever I'm debugging issues with builds, it's wonderful. Usually studios will have the build system, and then when you want to run it locally, there's like a bat file that tries to do the same, but doesn't quite do the same. That build locally button, if you click it, will open this wonderful little window. Again, part of Unreal Game Sync. Here, it's automatically filled out the changeless number that the build machines ran with, and the exact same command that the build machines ran. All you have to do is make sure you set the right workspace and whatnot, and you will get essentially the same thing the build machine did locally with very little effort. If you've ever worked with Unreal Game Sync, you probably try to get those badges in the CIS column to work. That requires running an IIS service called Unreal Game Sync Metadata API. It is the only IIS service I have ever run in my entire career, and I hate it. But Horde offers an API that is compatible with it. So you can simply point UGS at Horde and burn that service to the ground. Horde supports dev kits in several different ways. The first one is it can replace that spreadsheet you have. You all have it, that spreadsheet that tracks who's using which dev kit. Very simply, you just add your dev kits, and then users can come in, check out the dev kit, and have it automatically returned after 24 hours. It's not actually doing anything with the dev kit. It's just tracking who's using which dev kits at what time. But you can also assign ACLs, and you can put these in pools, so you can control which users or teams have access to which dev kits, that kind of thing. It's a simple feature, but it helps a lot. So to summarize, it's the opposite of a death by 1,000 paper cuts, right? It's all the little things. There's a whole bunch of little things all over the place that add up to such a wonderful experience. Sorry. So for us, we saw some of this, and we saw how cool it might be, and we wanted to start understanding how do we do this? How do we do this thing? So the next step in this journey of understanding is to understand how Horde works under the hood. For me, this is what made everything. This was the light switch moment in the brain when I realized that under the hood, after all of the complexity of what agents will run things, how do workspaces get synced, all of that, at the end of the day, Horde simply, I can't put that in big enough air quotes, simply runs build graph scripts in a distributed fashion. Once you understand that Horde is just running build graph scripts, you can work backwards from that and start understanding the rest of it. But that's what helped me. So Horde runs build graph. This is actually a really awesome thing because build graph does not actually depend on Horde. So if you are not ready to use Horde, because you shouldn't yet, but you're also not using build graph yet, this is something that you can action today. Start moving to build graph. Build graph is awesome on its own. And again, because Horde is just running build graph under the hood, like in the logs, you can see the exact command that it runs. You could run those same commands on TeamCity or Jenkins or wherever else that you're working, right? There's nothing actually super special there going on. So yeah, it runs build graph. It's great. One of the things that we found while we started doing this, our transition from TeamCity to Horde, was that all of our projects did essentially the same thing, really, right? All of our projects need to compile and cook and package. They need to resave packages, generate nav mesh, HLOD, whatever, right? But that's the same thing for all of them. So one of the things that we ended up doing is we ended up building a single, very large build graph script that all of our projects share. It's project agnostic. All of our projects share the exact same build graph script. And it's made it a lot easier to migrate multiple projects by keeping it agnostic. This leads to a semi-downside thing, which is there's no IDE for this thing. Build graph is an extension of XML, but it's not a programming language, and IDEs don't really know what to do with it. So it kind of sucks. That's also part of why I personally prefer having it in one giant XML file instead of many different ones, right? For me, being able to put, for example, a header like that at different sections in VS Code, I can quickly jump around to that, right? Because there's no proper IDE, I can't just control-click on a function and get to the underlying C# code, right? I can't quickly go to the declaration of a variable or the top of a loop or anything like that. So for me, having it in a single large file helped reduce some of these issues I was having. Everybody's, I think, going to be a little different on this. This is where we landed. This is what helped me. You don't have to do it that way. It does support importing or including other build graph scripts. So whatever works for you, but that's what works for us. One of the things that we learned early on was to just start small. We started transitioning the smallest jobs we could, things like resave packages or generate HLOTs or generate the tools. All of those sorts of things are what we started with. And we started with that for a couple of reasons. One, it let us start getting confidence in the system. It let us start understanding, how does Horde deal with issues? How do the Slack messages work? How does Horde fail? What do we do when Horde fails, right? We can start to understand all of that without trying to get everything working as well. We can just start with the simple things, right? This also helped build confidence in it in production and leadership and the development teams, right? We want them to want to move to Horde. We don't want to force it. We want them to want to move, right? Part of that is they don't want downtime. They want to know things will work. So by starting small and working up, we could build our own confidence and knowledge, but also just build confidence in the company, in the system, right? Horde is wonderful and all, but it is a little more tricky to deploy. There's no simple just like MSI installer or exe installer. There's a lot more to it. This offers a great amount of flexibility, especially if you are used to deploying things to the cloud and Docker containers. There's a lot of flexibility there, but it is more complex than TeamCity, for example. So I'm going to quickly run through some of the components of Horde so you have a bit of an understanding of what's going on. First up, we have the Horde server itself. This is the thing that does not necessarily the heavy lifting, but it's the bulk of Horde in the sense of the logic. This is what the users interact with. This is what deals with all that kind of logic. It serves an HTTP API and a gRPC API. Yeah, and we can scale it horizontally. It's stateless. It's wonderful. Next to that, we run the dashboard, that fancy web UI I was showing earlier. That is considered the Horde dashboard. Right? It's a React.js static website, right? So you can serve it via S3, or as we do, as we are all on premise, we just use an Nginx container. In front of that, we have a proxy to do proxy-y things. Horde does expect to all be run under one domain, so we do need to route requests for the dashboard one way and the backend to another way. So we use traffic. You could use whatever is applicable to your deployment patterns. Once we have all of that, really, our users should be able to connect to Horde. They're not going to see anything because it's not doing anything yet. But at that point, the user should be able to load the dashboard and then make HTTP requests to the server. Next to that, we have the Horde agent. This is very similar to any other agent, the TeamCity agents, whatever. Right? It's probably the part you will have the most of, right? And it's the thing that actually does the heavy lifting of running build graph scripts. Once it's told to do a thing, it does it, but it's executing build graph scripts. For us, we manage our agents and everything actually with Ansible, and Horde has helped make this a lot easier in that literally when we provision a new machine, we install the Horde agent, VS Code, Windows Stat, and P4V, and that's it, right? Horde has full integration with Auto SDK, so when you're configuring projects and configuring pipelines, you can tell Horde which jobs require the Auto SDK. Horde will make sure that the machine that the job is running on has synced the latest version of Auto SDK. It's always at latest. It will set the correct environment variables, and all of your SDKs magically get installed. It is wonderful. We no longer have to provision machines for specific projects or anything like that. Super wonderful. This is a bit of an optional component, the worker. If you are in a small deployment, you probably don't need it. As you scale, you will probably want it. But its purpose is fairly straightforward: to run the background tasks of Horde, right? To run the polling of perforce and the scheduling of tasks. And the idea here is just simply, we want to limit the blast radius of things going wrong, right? We don't want an increase in load on the server from users or something, causing our scheduled jobs to fail, or the scheduler itself going awry, because it's happened, to bring the server itself down, right? So again, a lot of flexibility in how we deploy this. And then very quickly, backing the server itself is MongoDB, doing databasey things, right? Redis for caching and queues, and then some kind of storage, right? That could be S3 or S3 compatible APIs, so MinIO, something like that. It could be just the raw file system, or it could be Horde storage. We don't use Horde storage, we use an S3 API, but so yeah, your mileage may vary there. Altogether, it can look something like this, right? For us, it looks like this. You can tell it was made by a game development studio because there's RGB, which makes it go faster. I don't know. But yes, we run all of the backend components, and well, we run everything on premise, but we run the backend components as Docker containers and VMs. The agents themselves are primarily physical machines. So we have some machines that are compiled and some machines that are cooked. They have different specs. Horde offers the ability to group agents into pools, and we can also have pools for different projects, not just different agent types, right? And then we do have some agents that are VMs. We have some, those agents are usually doing things like Docker builds or publishing to Steam or whatever it might be, the packaging itself. Things that are limited quantity of compile and cook agents just don't need to waste their time doing, right? My understanding is Epic runs all of this in AWS. I do know that there is code in Horde for auto-scaling EC2 instances. I have not used it. Good luck. Right. So that's generally the components of Horde. Again, because it's mostly all Docker containers, you could have a single Docker compose file that runs all of that on one machine. You don't need to have the complexity of many, many machines doing all these different parts. But again, the flexibility is there out of the gate, and that is wonderful. This was a fun one. So, and I have no idea how Epic does not run into this at all. But if you have Windows Server 2022, there are the defaults for the maximum number of TCP ports is not enough. Horde tries to be very smart. This is one of those things where Epic is, I'm not sure they're right on, but they've tried to be smart. They've tried to be special in the way that they do the parallel syncing. They've tried to make it faster and more efficient. The result of that is that the Horde agent churns through many thousands of TCP connections, many, many thousands of TCP connections. So it took us a little while, but you need to lower the TCP timeout, and you need to increase the maximum user ports. We did that, and our problem went away. Again, I don't know how Epic doesn't run into that, but it was a problem. So one part of me really hopes I've excited you. One part of me doesn't, because I don't want to be responsible for the problems you come up with when you inevitably go and do this. To that end, I just want to remind you, this stuff is not production ready. It's not considered production ready at all. And to that end, here be the dragons. There are no releases of Horde. They don't line up with Unreal, 5.1, 5.2, or anything like that. If you want Horde, you go to the GitHub or you go to their Perforce, whichever you have access to, and you just pull latest and hope it works. There's no release cadence for it or anything like that. That also means there's no release notes at all. And it is not unheard of at all for them to change configuration options for something that was optional to become required, or the name of a configuration option to change. If you're deploying Horde, you need to be very careful about that. You need a staging environment, and you need to pay attention to the diffs of this kind of stuff. So it makes releases and upgrades a little more difficult. That is for sure. To be clear, the team behind Horde is helpful when they have time, but this is not a released thing. They're not there to support it yet. You are on your own if you deploy Horde, right? There's no retention mechanism at all in Horde. Again, Epic runs it in AWS, so they have the infinite capacity of S3. We happen to run on premise. We don't care to spend an infinite amount of Fortnite money on storage, and we can't just magically grow our storage either. So this is a problem we've not sorted out yet, but yeah, there's literally no retention mechanism at all. It's the Epic way or the build it yourself way. Yeah, they're building Horde for them at this point in time, right? They've not released it, not trying to build it for everybody else. They're trying to build it for their teams internally. In a number of ways, that's awesome, because we get to learn better about how they do things internally, And the better we follow what they do, in our experience, the better off we are. Right? When we first started deploying Horde, we had an issue where it just would not build our projects at all because we structured our Perforce depots differently than them. We restructured our Perforce depots, our issues went away. It sucked for the devs to resync everything, but at the end of the day, it was the better option. In comparison to that, there's other things like this. That continuous integration category that I mentioned earlier in the presentation, they call that category incremental instead of continuous integration. And the view or the layout of that category is hard-coded to only be that way for the incremental tab. So us wanting to call it continuous integration meant we had to go and, first of all, figure out there was another layout at all, and then edit the code to call it continuous integration because that's what we preferred. But it's a balancing act, right? Do you want to take ownership of those changes that you're inevitably going to have to make, or do you just do it the way Epic does it and hope everything is going to be okay? There's no visibility of server-wide queues. Again, Epic run this in AWS. They have auto-scaling EC2 instances. Us being on-premise, we try very, very hard, and we're very careful about how we balance our pools of agents, right? Which projects have how many machines, how many compile agents in the pool, how many cook agents, all of that is very important to us. And we have no single pane of glass to look at that. We have to go through every pool one at a time and look at them, or wait for somebody to complain, right? So yeah, I don't have a solution for that, and it sucks, but this might, I don't know how many other people do this, but again, because we're on premise and our machines are not constantly being recycled, our incremental workspaces can get dirty sometimes, right? This is the workspace that does not clean itself between every job. It's just redoing the compiler, the cook on the same workspace. Super beneficial for CI. Our compile times are much lower in that sense, but it's less reliable. Sometimes some things get left alone in that workspace that impact the compiler or the cook, and we want to be able to clean that up some way. For us, when we were on Team City, we would run a job every Sunday afternoon that completely nuked every workspace from every machine, and then on every machine ran for every workspace a compiler, a cook, or whatever that machine was responsible for, so that come Monday morning, everything had been cleaned, but also a job had been run, so things were synced, the incrementals were still fast, all of that. There's no way to do that in Horde at all. So yes, and again, I don't think Epic intends on changing that because that's not how they use it, but it hurts us. There's also no dashboards at all. There's not really any support for dashboards. I love my Grafana. I love having dashboards about things. And Team City and Jenkins have different plugins to provide dashboards, that kind of thing. There's nothing out of the box for it. We've done the very hacky thing of a Python script that pulls from Mongo and shoves in a Postgres database so that we can get that. It's just Grafana pulling from a Postgres database, but yeah, there's nothing out of the box for it. So again, build it yourself or do it the Epic way. The list of issues here goes on and on and on, right? The issues come up all the time. You might have pulled the wrong version from Perforce or GitHub, wherever you are getting it from. That TCP issue, Epic never experienced it. They don't. When we go to them, we're like, hey, we have a problem. They're like, and you know, when these problems crop up in production and your development team can't work because Horde is down, that is a problem, right? With Team City, you have a support contract with JetBrains, and they will help you solve these things. None of that exists here. There is no support for this. So just a final sort of reminder, this is not ready for production at all. Yeah, that's kind of all I had to go on for now. Thank you very much for coming out. Again, my name is Reiner Block-Anderson. I've been with Splash for about 2 years. We are hiring. If you want to work on cool future epic things like this, like Horde, virtual assets, yada, yada, we are rolling that out, and we are transitioning to a 4-day work week. So that's cool. And then finally, I was talking to the CTO at Splash yesterday, Arnaut, and I was complaining about how many presentations gloss over the details. They talk at a high level of, you know, all this cool stuff, but they never actually tell you how to implement things. So there's our build graph scripts. There's our Horde configs. Please don't use them because they're like old versions of them and they don't work, but that is them. Yes, I won't help you when they break, but they might be a good reference if you want to go and try things. So yes, as a reference, they may work. And that is that. Is there any questions?
Thank you so much. Absolutely fantastic talk.
Cool.
Have you looked into doing any kind of automated testing stuff through Horde?
Yes, we actually do. It's way too far back. I won't find it. We run gauntlet automation tests. So we also do an editor boot test kind of thing and make sure certain maps can load. And that is fully supported. You just run gauntlet through it. If you are running, we don't do this ourselves. We're still figuring gauntlet tests out. But if you do run gauntlet tests that involve dev kits, Horde has a section for listing dev kits, and then Gauntlet can reach out to Horde and request a dev kit. So you don't have to attach dev kits to specific build agents. Any build agent can just request a dev kit, be given the IP of it, use that, tell Horde when it's done, and it goes back to the pool.
Awesome. Thanks.
I'm just going to go back to the end. I don't know why I was...
Hi. Really good talk. I was just wondering, have you heard anything from Epic about like when this will be production ready or even close to production ready?
No, I do know that they still classify it as experimental. From other things they've released, they usually go from experimental to beta to release. And the beta to release usually takes a couple of engine releases to happen. And this is still experimental, so we'll see. I actually have no idea.
Cool. Thanks.
Cool. Thank you very much.